So I hope you have really tried on your own. Remember, it is not a good practice if you are just listening to how I break down the question for you and then you are like, oh yeah, 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 this is the way. Because sometimes when you first attempt it, you will realize that, you think of it a very different way. So for example, when you are looking at this question, did you realize that in the context, we have actually stated that it is released from rest. So because of that, at the initial state, your velocity is actually equals to 0. So because of that, if you try to form your energy store at the beginning, which is when the ball is being lifted up, you will actually only have GPE, and actually your kinetic energy is equals to 0. Right, and as the ball is about to strike the wall, so down here it is just before it hits the wall, right? So what is the difference between before hitting the wall, hit the wall, and after it hit the wall? Now before it hit the wall, it means that all the energy are still stored within the ball. But if you are talking about after it strikes the wall, some of the energy may be transferred to the wall. So because of that, down here, you will have your maximum velocity, right? So down here, you can also see that when as the ball swings down, it actually hit the h equals to 0 level. So because of that, your GPE will be equals to 0 and you will have some KE, right? So down here, if you look at the energy store, right, all the energy is stored within the ball. So because of that, when we apply the principle of conservation energy, we would say that the GPE at the very beginning must be equals to the KE at the end, right? So we have this initial state equals to final state. So if you apply the formulas, you will be able to find the answer. And you also notice that when we do that, the mass of the ball is actually irrelevant to our question. So I hope with this you are able to find the answer. As for the next question, you can see that by framing the question correctly, you should be able to see that at the very beginning, there is some kinetic energy because it is already moving with 3 meter per second, and there's already some height. So there's GPE over here. But as it reaches the bottom, the final state, you will see that there is actually no more GPE, right? But there will be KE because as the ball rolls down, it will continue to roll, right? So when you apply the principle of conservation of energy, initial state equals to final state, you will have KE at the initial state plus the GPE at the initial state will be equals to the KE at the final state. So again, as you expand each of the term, remember top down, please stop writing things like this: KEI equals to da 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 da, GPEI equals to da 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 da. This is not the way to go forward, because in JC, in poly, in uni, you would have to learn how to develop your equation top down with the equal sign right at the center. So please start changing your habit, right? So you will have this, right? Then have MVF square. So be mindful of the square. Then here you will also notice that the mass of the object is again irrelevant, right? Then you can go on and solve this. So for question 3 is the same, right? If you look at the initial state, and if you set h equals to 0 here, you will notice that the initial state of all 3 balls will be just GPE, right? And because they are falling from rest, yeah, did they say fall from rest? No, they didn't say. So we have to assume sometimes. But in exam, if you find that you are not sure and you're quite certain that you have read the question carefully, please raise your hand and ask the invigilators. Okay, so here we will assume that it is fall from rest. Okay, so because of that, down here the KE will be equals to 0. Yeah, and then towards the end, there's no more GPE because when you reach the bottom, H equals to 0. So the only thing over here would be GPE equals to 0, and there's KE. So if you look at the energy store and if you apply the principle of conservation energy, you would actually see that your GPE at the initial state must be equals to the KE in the final state. And if you expand them into your formulas, again you will see that actually the mass is irrelevant. And you can see that A, B, and C, as long as they have the same height, you will end up with the same final velocity, right? So for example, if now I want to prove this, I will prove my argument, I will make my V the subject of my equation because I want to see what does V consist of. So then I will do my algebra. So before I do that, maybe I shift this a little bit to the left. Yeah, then I continue developing this. Maybe I use black. Yeah, so I bring the half over, 2gh equals to V squared. Then my V will become square root 2gh. And you can see that the final velocity, which is the velocity over here, right? That's my final state, right? My V is actually equals to 2gh, right? Does it involve mass? No. As long as they are above the same height, they will reach the ground at the same final velocity. But we all know that in real life, this does not happen, right? Yeah, if your object is falling in a different path versus a straight path, you would know that the final velocity is different, right? So why? Like I said, this particular context is an oversimplification, right? When we consider all the other resistive forces that will affect the context, you will be able to actually come to a conclusion that is very similar to reality. I mean, why develop a whole field of academic study when your conclusion is different from real life, right? So it is different now because we frame the question, we oversimplify it so that you can learn the basic content. Yeah, so I want you guys to write your own, and I will collect to mark to see whether you can express yourself correctly, because one of the key thing to getting your good grades is that you are able to articulate what your thought is. So now I have helped you frame your thinking. What I need you to do is to articulate using your own words, okay? And remember, don't overwrite, right? Try to keep to 3 lines. If not, I give you maximum 4 lines. Okay, so hopefully I will be able to come back for the next lesson. If not, then we will either Zoom or do a YouTube video, something like that. Okay, see you. Bye bye.